Welcome everyone to our track-based void monitoring webinar. I will kick this off with a few practical points for today. This session will be recorded and shared. Please feel free to ask questions in the chat during the session, and we will address them at the end. Okay, let's get started. I will hand this to Morten.
Thank you, Christina. I'll start with a quick introduction of today's team. My name is Morten Stig Jørgensen, and I work as a sales manager and at Rail Monitor. With me today, I have Niels Juhl, our CTO, who will bring in the technical perspective behind the monitoring data and how we work with track behavior under load. We also have Christina Kelder-Wesenberg, our CMO, who will help guide the webinar and support the Q&A. Our goal today is to keep the discussion practical and grounded in real railway projects and share experiences that you can hopefully use as inspiration in your own work. I'll hand it over to you, Niels.
Thank you, Morten. Good morning, everybody. I hope you have a great day. I will start the presentation. And before we get started, I will briefly walk you through today's session. Our goal is to share some practical experience from real railway projects. We will share some of the approaches we have found to work well in practice, along with our recommendations for using dynamic deflection data to support maintenance planning and monitoring during critical projects, such as, for example, auxiliary bridge installations. We hope that you will leave today's webinar with a few new ideas and practical insights that you can use as inspiration in your work at home. With that, let's start by looking at why hidden voids remain one of the biggest challenges in the railway infrastructure. Voids are what we call a silent risk. They often develop gradually and remain invisible for a long time because the track geometry in an unloaded condition may still look normal from the outside. From our experience, the challenge is rarely just as a void exists, but understanding how it develops, how fast it changes, and when it starts to require attention. When sleepers are no longer properly supported, the track can begin to move differently on the passing trains. Over time, this can accelerate ballast degradation and lead to more reactive maintenance. This becomes especially important for infrastructure owners because uncertainty often leads to conservative decisions, speed restrictions, or unplanned interventions. Our recommendation is therefore to look at void monitoring as a decision support tool, not just a detection method. The value from following the development over time, so maintenance can be planned earlier, prioritized better, and based on measurements rather than assumptions. So when working with voids, our recommendation is to focus less on a single measurement, meaning how the actual sleeper is moving, and more on how the actual track behaves over time. A single inspection can tell you what the situation looks like at one point in time, but continuous measurement on the normal train traffic can show how the track responds under load and whether the response is changing. This is where the value comes in. You can start to whether a condition is stable, improving, or developing into something that requires attention. From our experience, this gives infrastructure owners and project teams much more stronger basis for planning, maintenance, setting thresholds, and deciding when action is actually needed. The goal is not to create more data, but to create a clear understanding of the track behavior behind the data and the understanding of what turns monitoring into decision support. So, auxiliary bridges projects are a very good example of where monitoring can give immediate value. We have two different materials that are supporting the rail, and the transition zones from each side is the zone called zone of influence. In these projects, our recommendation is to focus on stability and load response through the full execution period, being the full contraction period, not only at a planning inspection points. When an auxiliary bridge is installed or removed, the load distribution changes, and the track still needs to remain safe for live traffic. From our experience, continuous monitoring helps the project team to understand whether the track is behaving as expected or whether movements are started to develop in a way that needs attention. This gives engineers and infrastructure owners a stronger basis for decision during this execution. It can support dialogue between the contractor, consultant, and infrastructure owner, and also help the team to respond earlier if predefined limits are approached. So the value is not measurement, it's the confidence during a critical plan of the project. And if you look into the picture here, you see actually that here we have an example of sensors placed in the track in this zone of influence area upon this auxiliary bridge on both sides of the track. And this is of course in two tracks at this time. When we talk about maintenance planning, one of the key recommendations is to use monitoring to prioritize where attention is actually needed. Not every location develops in the same way. Some remain stable, while others show increasing movement on the load. This is sometimes shown by the measurement train, but since the measurement train is only driving through the track for a given period, this continuous monitoring is possible by adding sensors. This picture is from a real auxiliary bridge project where we have monitored both dynamic deflection but also a static track geometry like cant and twist. And with these tilts, it gave a sensor setup. This combination gave the project team insight on both how the track moved on the train load and also the structure remained stable during the project. From our experience, this is where monitoring becomes valuable for maintenance planning. It helps to identify where voids are growing, where the intervention should be prioritized, and how maintenance can be planned around available traffic windows. It can also be used after tampering and other interventions to confirm the efficiency of the tampering and if the effect has been achieved. On the next slide, I'll show you an example of how this type of development can be followed week by week. So now we're converting this picture here into a graphic situation. Here we have the auxiliary bridge. This is a steel bridge. We have ballast on both sides of the track of this bridge. Sensors are added here, one on the first sleeper of each side of the bridge, and then approximately 10 to 12 meter next to the bridge. What we see here actually, this example is how we recommend looking at the development over time. Here we follow the same location week by week. In the beginning, you see that the deflection here is in average approximately 0. So the ballast is quite stable. And week by week, it is actually moving in this part here. on both sides of the rail, because each of these sensors here are showing these data. In practice, the trend is more often valuable than a single measurement itself. It helps the maintenance team to understand whether a condition is stable or deterioration, and whether action is needed soon. In this way, that supports the better decision, not just knowing the condition today, but understanding what is actually behaving. Upon this time, we talked about collecting measurements, but in our experience, the real value does not only come from the measurement itself, it comes from turning this measurement into information that people can actually act on. Our recommendation is to think beyond monitoring and focus on the decision support. A good monitoring platform should bring all relevant information together in one place, making it easy to understand what is happening, where it is happening, and whether it requires immediate action. It should also remove the need for people to continuously watch a dashboard. Instead, the system should notify the right people when understanding and something changes. Based on predefined thresholds, changes in behavior and each personal responsibility. Not every alarm or notification requires immediate intervention. Some situations require actions today, while others can simply be planned into the next maintenance window. Helping the users distinguish between those situations is, in our opinion, where the software creates the greatest value. Ultimately, the goal isn't to create more data, is to help the people make better decisions with confidence. And if we use this different data here, we see that we zoom here on a single sleeper. So you need to understand that here a sensor is responding on one sleeper. Each of these orange dots here is a train passage, and this is from December last in 2024 and 3 months ahead. So here we are looking at the condition on one sleeper. Over time, the development of the void is approximately down to 10 millimeter every time a train is passing, and then there is a tampering going on here, and then it moves back to approximately 0. After a certain while, it starts to develop again. So it's quite clear here how the efficiency of the tampering process is and how the ballast is supporting the individual sleeper. So this is a quite detailed picture of the entire situation. And from our perspective, this illustrates the real value of continuous monitoring. It is not just detecting a void, it is about understanding how the condition develops, confirming that maintenance has had the desired effect, and then follow the asset over time. And this gives the infrastructure owner confidence that the intervention has worked, and also provides an objective basis for deciding when the next intervention is actually needed. Zooming a little bit more out for the entire section of the track, where sensors like these, as you see here in the picture here, this is the sensor monitoring both the static track geometry, but also the voiding. Here we see that all individual sensors that are positioned here along the track, showing data from the average movement from week 5 this year and also this week. Here it provides the average movement over every week. And instead of looking at only one sleeper, so only this sleeper and this sleeper and this sleeper, over time, we're looking at a much longer section of the railway. This gives the maintenance team an overview of the entire monitored area and quickly highlights where the location that deserves attention, which is in this part here, where we have seen there has been a development over the last weeks, from week 5 to week 25. So this is, for example, here the data helps to indicate whether a location may require tamping. A previous tamping intervention has had this desired effect. The ballast has become overly compacted. Additional investigation is of course then needed, or whether the section is simply behaving as expected. Combination with notification, engineers don't need to continuously monitor the system itself. So the system actually provides notification if a certain void is too high. And in areas where some standards saying in high-speed rail, the supporting ballast may only have a void of maximum 3 millimeter, then of course we have a certain limit where you can get a notification. And the platform can notify the responsible person if the thresholds are exceeded, or if a sudden change in the behavior is detected. We have seen in flooded areas, the flooding or the water remove suddenly the ballast, and it is not over time that the void is developing. It is a sudden change, which also indicates that intervention is needed, or at least somebody needs to look at the information to find out whether they should do something. This means that the focus shift from watching data to understanding what the data is telling you, and also deciding when action is actually required. And by this, I will end my presentation. We now have a Q&A session, and the goal is, of course, not to provide more data. The goal is to make better decisions. The real change, or the message we hope that you have had from this session, and from our experience, continuous monitoring creates the greatest value when it helps infrastructure owners and project teams to understand how the condition develop over time, prioritize maintenance, and make decisions with greater confidence. We also hope that some of the examples, experience, and recommendation we shared today have given you inspiration that you can take back and apply in your own projects. I will thank you very much for joining today. And with that, I would like to open the floor for your questions, and Morten, Christina, and I will be happy to answer them. Thank you. And if you have some questions, feel free to write them in the chat. And of course, also we are also more than happy to answer if you write an email to us and so on. But if you have some questions we need to arise here, you are free to open. And if not, then I assume that you have understand everything. I'm very happy about that. And I can tell you that we have people in this webinar from more or less broad part of the world, from Japan to Europe to I think South of America. So it's more or less the same countries that are participating in the World Cup. Unfortunately, Denmark is not joining, but we'll hope we'll get there next time.
We'll cheer on Norway. So.
Yes. It seems like there's no questions, and if there's no questions, I'm happy that you joined, and I will wish you a nice day and also a nice summer. Thank you.
Thank you.
and take care.
Take care.
Take care.
Have a nice summer.